In this video, I'm going to talk about glycolysis, which is the first part of respiration. There's quite a lot of detail in glycolysis, but for the overall picture, refer back to one of the other videos, which is an overview of respiration. Now, respiration has 4 stages. Aerobic respiration has 4 stages. You have glycolysis, the link reaction, Krebs cycle, and oxidative phosphorylation. As I said, this video is only going to discuss glycolysis, but it will talk about what happens in the beginning parts of aerobic respiration and what happens in anaerobic respiration. There are two levels of detail really that you need to learn, or you could learn for glycolysis. I'll talk about both of them. I'll give an overview and then split it down a little bit more, but I'll explain when I split it down what's going on. So we'll go straight into it. So in glycolysis, we start with glucose. I'm going to try and write it quite small. Glucose, which is a 6-carbon molecule. Now, for some specifications, what I'm going to do now is fine, okay, for the first part of glycolysis. Well, for glycolysis. The first bit that goes on is glycolysis is transformed into 2 molecules, so 6 carbon here, and it's broken down into 2 molecules, so 2 times triose phosphate. It's 2 times triose phosphate, and that has 3 carbons each. The way this happens is 2 ATP, 2 times ATP go in. But remember, ATP has 3 phosphates. These are the phosphates. And when it loses this phosphate, it ends up with 2 phosphates and then 1 floating around, so ADP then. There's a video on that as well if you're unsure about that. But the ATP here comes in, and as you normally see, 2 times, because 2's gone in, ADP would come out. However, normally you'd see the 3rd phosphate floating around with it, but here 2 times of the phosphate are added to the glucose molecule, and it's broken down, which makes it triose phosphate. This step from the glucose to 2 times triose phosphate is called phosphorylation. And it's called phosphorylation because you're getting some phosphates added. Okay, so that's this section from here to here. The second part of glycolysis that takes place is the 2 times triose phosphate, 3 carbons, get broken down further into 2 molecules called pyruvate. And that also has 3 carbons. And when I mean like that, it gets, because I'm writing 2 times, that can be a bit confusing. You start off with your glucose, goes through one thing, but it makes 2 of this. So I'll just do T, okay? And then that goes down to make its pyruvate. That's what's going on when you're writing 2 times, but rather than drawing arrows everywhere, it's drawn like this. And the transition from the triose phosphate to the pyruvate takes place here, and you have 4 times ADP plus 4 P going in, and what you get here is 4 times ATP. Now, it's important to note that you've got 4 ATP here, but you've used 2 ATP. So we had to use 2 ATP to make 4 ATP. So what happens here is 2 of these ATP go back to start again, which gives you a net gain of 2 ATP. So glycolysis on its own produces a net gain of 2 ATP. Okay, it's very important that you understand that, a net gain of 2 ATP. This ATP now will go off and just be used as cellular energy. The other thing that happens, another thing happens to transform triose phosphate to the pyruvate, is that it gives up 2 hydrogen ions times 2, and NAD, 2 of them, because there's 2 hydrogen ions, comes in, picks these up, and then you'll get 2 times 2 times reduced NAD. 2 times reduced NAD. If you remember back to some chemistry, you have the thing called oil rig. Oxidation is loss, reduction is gain. So in this case, 2 hydrogen ions have been gained here, so that's a reduction. Reduction is gain. These guys have gone over there, so it's a gain, but we call it reduction. What's happened here is the triose phosphate has lost these ions, so that's called oxidation. So the first stage was called phosphorylation. This stage, from the phosphate to the pyruvate, is called oxidation. So you've got these 2 stages, phosphorylation and oxidation, which transform the glucose, which is a 6-carbon molecule, into 2 times pyruvate. During that process, it creates 2 times ATP, a net gain of it, and it also creates 2 times reduced NAD, which will go to oxidative phosphorylation stage, which again, if you're confused that, look at the other video that I've done on the overview. Now, this level of detail for glycolysis in aerobic respiration is fine for some specifications. In aerobic respiration now, pyruvate just goes to link reaction. Straightforward. However, in some specifications, such as the new AQA specification, that's the 2016 specification, the phosphorylation is broken down into more stages. So I'll break that down as well, but I'm just talking about this area. The story from getting glucose to your triose phosphate. So you end up with your glucose, 6 carbon, and what happens is, this is all phosphorylation, by the way, okay, because it's just going to get it to the triose phosphate. What happens is 1 ATP comes in, drops its phosphate off, and ADP comes out, but only 1 ADP. Oh, come on, play a game. I'll just leave it. ADP. And this makes glucose phosphate, because a phosphate's been added. Then another stage takes place where another ATP comes in the exact same way as before, drops its phosphate off, ADP leaves, and then it makes another molecule called hexose. Oh, my anchors are messing around. Bisphosphate. Okay. Now, 2 ATP's gone in, and 2 ADP's left in the exact same way as here. Okay, but we've just zoomed into this area. The glucose is 6 carbon, glucose phosphate is 6 carbon, the hexobiphosphate is 6 carbon, and then this is just split up then to make your 2 times triose phosphate. Now, I hope that hasn't confused you too much. You get your 3 carbons here, but there's 2 lots of them. So this is just a zoom in of this stage here. So this is also phosphorylation, just in more detail. Depending what specification you're on, depends on how much detail you want it, they want it. But for the AQA specification, this is the DL they want. So you go from your glucose through all these little steps to your triose phosphate, and then oxidization is just the same. In all instances, you end up with, in aerobic respiration, whichever spec you do, your pyruvate now goes to the next stage, the link reaction, which will be covered in another video. That's in aerobic respiration. But anaerobic respiration is something that's spoken about in the video where where no oxygen is used. So all that before is aerobic respiration includes all 4 stages I meant to. But in the case of anaerobic respiration, these products, the pyruvate is recycled and goes back again. Okay, so anaerobic respiration only deals with glycolysis. Okay, and it takes place differently in depending what organism it is. So in plants, you have a process called alcoholic fermentation. As the name suggests, this is where alcohol comes from. And what happens, so before I said the pyruvate in aerobic respiration just carries on to link reaction. But we're not talking about aerobic respiration, now we're talking anaerobic. And in plants, the process is called alcoholic fermentation. And what happens is you get your pyruvate that's happened in glycolysis. It loses a CO2, so it leaves, which leaves ethanol, and then reduced NAD, I'll draw it down here, reduced NAD comes in, drops off its hydrogen ion and leaves as NAD. And that leaves us with ethanol. Okay, now what happens, this NAD will go back to here and come back in the oxidation process and pick up some more hydrogens. Because remember, there's no oxidative phosphorylation in anaerobic respiration, so this just cycles round and round and round. But anaerobic respiration just keeps staying in the glycolysis, but it produces this 2 ATP gain but that's all it produces, and this NAD needs to be recycled. And this process of breaking down the pyruvate to allow for the oxidized NAD to be regenerated allows glycolysis to carry on. The other kind of organism is when we talk about animal cells. Animal cells and some bacteria. Okay, but you'll be familiar with this when I say it. And in animal cells, the process is called lactate fermentation. Sorry if my writing's a little bit less neat than normal, but I'm trying to squeeze this on. Okay, so in animal cells, the process is called lactate fermentation. You get your pyruvate, and in this time, it doesn't lose its oxygen. It gets produced straight into, it doesn't lose its CO2, and it gets produced straight into lactate. Okay, by the same process of what goes on here. So a reduced NAD comes in, taking an oxidized NAD out. Okay, remember oxidization is loss. Okay, oil rig. So this is an oxidized NAD. And it goes away, goes back to starting the glycolysis, so then that 2 ATP net gain can be made. Lactate is also known as lactic acid, and that's when, if you're training really hard and you go over your aerobic threshold, your body's not getting enough oxygen, and because it doesn't get enough oxygen, it turns into an anaerobic state, which means it can't produce enough energy for the cells, and it just produces this little 2 ATP at a time, and then lactate builds up, and that's why your muscles get tired when you're doing exercise. I hope all that makes sense. I'll do a very quick recap, okay, of the overview. So in aerobic respiration, where oxygen's used, all these stages are used, okay, all 4 stages. But in anaerobic, only glycolysis, and the rest of this video talks about glycolysis. You start with your 6-carbon glucose. Phosphorylation occurs where 2 ATP come in overall, add a phosphate, add 2 phosphates, and 2 ADP leave, and then they'll go and get recycled again. This process makes 2 times triose phosphate. It's called phosphorylation. 4 ADP plus 4P come in, and 4 ATP leave, and 2 hydrogen ions are left and jump on board 2 NADs, which make reduced NAD. In aerobic respiration, this reduced NAD will go to oxidative phosphorylation, and you'll find out what happens in another video. In anaerobic respiration, this just goes back to here, and then drops off and makes this product, so the NAD can be recycled back to start glycolysis again. We end up with our net gain of 2. Our net gain of 2, we have 2 ATP being used, but we make 4 ATP. So glycolysis makes a net gain of 2. And our final product is pyruvate. In aerobic respiration, it does something else, but in anaerobic respiration, it does something else, but in aerobic respiration, it goes to the link reaction. In anaerobic respiration, in plants, it's called alcoholic fermentation. The pyruvate loses the CO2, becomes ethanol. Then the reduced NAD comes in, drops off the hydrogen ion, becomes ethanol, and that build-up gets made within the plant. The same in animal cells, or similar. Pyruvate, the reduced NAD comes in, takes the hydrogen ion, becomes NAD, oxidized NAD. produces lactate, but because of this thing here, glycolysis continues and produces a small amount of energy, but you get this build up in the muscles. It's a lot to take in and a lot of lines being drawn everywhere. If you've watched this video and found it slightly confusing, look back on the respiration overview video, and hopefully it'll make sense before you watch other videos that progress to further stages in aerobic respiration. Thank you.